Started.
Hey Algebra 2! I'm sure you have all been waiting with bated breath for your next installment. I seriously thought about putting makeup on and doing my hair really fancy just to shock you so I look like a real video person. But I've been shoveling snow all morning, so here I am. Today we are going to be talking about ratios. You have some familiarity with ratios. We've used them in the past. And I think you'll enjoy doing them. We're going to do some more of the chemistry type problems like we did last week, but we're not doing percentages this time. We're going to be doing ratios, which is similar because a percentage is really a ratio out of 100. But anyway, okay. So the type of problems you're going to be working on are like the one that's here on the board, okay? And I will read it out loud. It says, in the parking lot, there are 72 vehicles. All right, in the parking lot, there's 72 vehicles. Comprised of cars and motorcycles. Only cars and motorcycles. No minivans. Apparently no large families. Anyway, if the ratio of cars to motorcycles is 3-to-1, how many cars are there? Okay, now this is a very simple one. And what we're going to do is we're going to set up what ratios, all the possible ratios that you would have if you were working with this. And then the ratio, we'll look and see which ratio do we need to answer this question, okay? So if we have a parking lot that's got 72 vehicles and the ratio of cars to motorcycles is 3-to-1. So we know that cars to motorcycles, I'll just call them MCs, motorcycles is 3-to-1, okay? Now what we have to recognize is we have a couple of other ratios. We would have motorcycles to cars, which would just be flipping it. But we also have cars to vehicles, and we also have motorcycles to vehicles. Okay, so the cars to vehicles, if this makes sense, is actually 3-to-4 because there's 3 cars, right? 1 motorcycle, which makes 4 total. I hope that makes sense because that's okay. So if I have 3 cars to the total number of vehicles, I have 1 motorcycle to the total number of vehicles. Then what you're going to do is you're going to go back up there and read the problem. The question is, how many cars are there? And we are given how many vehicles there are. So we have to use the ratio that has cars to vehicles. Okay? So what we're going to do is we're just going to pull that over here, and I'm going to say, I'm going to do cars to vehicles, and I know that the ratio is 3-to-4. I don't know how many cars there are, but there are 72 vehicles. Okay? And then we're going to use the same strategy that we use for the percentage problems, and I'm going to use my cross product, right? So I'm going to get 72 times 3 is going to be equal to 4x. Well, 72 times 3 is, let's see, 216. Divide them both by 4, and I'm going to get that there are, let me see, 216 divided by 4 is, there are 54 cars in the car. Now we could also figure out how many motorcycles there were. We would use the same thing and we would have 1/4 equals x over 72. Or once we figured out cars, you could probably just subtract. Okay, so I'm going to have Hannah stop recording for a second so I can put a different type of problem on the board.
Done.
Welcome back. Although you probably didn't go anywhere, I just did. Anyway, the second type of problem that we're going to talk about are the ones that we would do in chemistry. And our problem here is to find the mass of magnesium in 1,560 grams of magnesium oxide. So, once again, we're going to use ratios to solve these. I've lost all my other colored markers, so we're just going to stick with blue for now. But if you have that chart in front of you that we used before, I just saw the marker on the floor. Anyway, if you had that chart, we would find out that magnesium has an atomic mass weight of 24, and oxygen has an atomic mass weight of 16. So that brings the weight of magnesium of our compound to 40. That's our total. Okay, so we're going to do the same exact thing again, where we're going to look at the different types of ratios that we can write in order to solve this problem. So we could come up with, we could do magnesium to oxygen, right, which would be 24 to 16, that's what we were calculating before when we did this, is we were calculating the percentage of magnesium in the compound. But now we're going to figure out the mass in an overall compound. So if I was doing magnesium to oxygen, I would do that. If I was doing magnesium to my compound, right, then I would have 24 over 40. And if I was figuring out, oxygen in my compound, I would have 16 over 40. Keeping in mind, I'm looking at the 3 different ratios that I can get coming out of this information. If I had a compound that had more elements in it, I would have more possible ratios. But all I have here is magnesium, oxygen in my compound. So then I'm going to look at it and say, all right, I want to find the mass of magnesium, right, in this total compound. So I'm going to use this ratio because that's what I'm trying to calculate. So I'm going to take my ratio, I'm going to write it down here, and I've got 24 over 40 is equal to, I don't know how much, because remember this is magnesium over my compound, over 1,560 grams, okay? This is atomic mass units, but those are going to cancel out. So I'm trying to find grams. So I'm going to use my cross product, and I'm going to get that 1,560 times 24 is equal to 40 times x, okay? Then I would punch this in my calculator. I'm going to grab the calculator. All right, so I'm going to put it in my calculator, and I've got 1560 times 24. That gives me 37,440. 37,440. Then I would divide by the 40. Now, when I punch this in my calculator, I don't usually write all of this out. I usually just multiply the two that are across from each other and divide by this one, which is essentially what we're doing. But if I've done this correctly, I should get that x equals 936 grams of magnesium in that compound. So I have 936 grams of magnesium in 1,560 grams of the compound. I'm going to scan it and send it out to you. I will send you the A page completed, or at least half completed, written out so that you can look and see what I would do to complete it, and that you can use it as a guide to go over the next couple of pages of homework. That's it, and I'll see you on Thursday.